We humans love to make sense of the world, passing down stories and rules, our so-called laws of physics and nature. These rules become so ingrained that questioning them feels absurd. But the universe doesn't always fit our tidy narratives. Nature hides subtle truths just beneath our assumptions. Today, we'll peel back the layers of misconception and challenge what we think we know. Prepare yourselves. The world is not always as it seems. You've heard these facts everywhere. School, movies, even from your smartest friends. But today, we're busting 5 physics myths that even NASA fans get wrong. Let's start in space, where the mysteries of gravity and motion come alive in ways that can seem almost magical. Here, astronauts float inside the International Space Station, drifting gently as if the rules of physics have been suspended. The myth? There's no gravity in space. It's a common belief, but it's not quite true. If that were true, the moon wouldn't orbit Earth and satellites would simply drift away into the void, never to return. Gravity doesn't stop at our atmosphere. It stretches across the cosmos, holding planets, moons and stars in their orbits, weaving the fabric of the universe together. So why do astronauts float? It's not because gravity is gone. In fact, gravity is still very much at work. They're in freefall, moving sideways so fast that as they fall toward Earth, they keep missing it, circling endlessly. This is what we call orbit, a perfect balance between falling and moving forward, creating a continuous path around our planet. At the ISS's altitude, gravity is still about 90% as strong as on Earth's surface. The pull is nearly as powerful as what you feel standing on the ground. If you stood on a tower as high as the ISS, you'd feel only slightly lighter, hardly the sensation of being weightless. The sensation of weightlessness comes from motion, not location. It's the experience of falling, not the absence of gravity. Satellites, space stations, even the moon, they're all falling around Earth, held by gravity's invisible grip, locked in a cosmic dance. If gravity vanished, the moon and satellites would fly off into space, lost forever in the darkness. So, space isn't gravity-free. It's a place where everything is in a constant, graceful fall, guided by the laws of physics. Astronauts aren't escaping gravity, they're surfing its curve, riding the invisible waves that keep them in motion. Their floating is a dance with gravity, not a defiance of it. Every movement is a response to gravity's pull. The next time you see astronauts drifting, remember they're not weightless. They're expert surfers on the ocean of space-time, moving in harmony with gravity. The universe is bound by invisible threads, not empty of force. Gravity connects everything, from the smallest pebble to the largest star. Our world and everything orbiting it is held together by gravity's unending pull, shaping the very structure of the cosmos. The image of a gravity-free space, just an illusion, a trick of perspective and motion. The reality, a cosmic ballet choreographed by gravity, with every object playing its part in the grand performance. So the next time you hear "no gravity in space," you'll know the real story. Gravity is everywhere, shaping every moment. Space is not an escape from gravity. It's a showcase of its power, a testament to the invisible force that binds the universe together. Back on Earth, let's tackle a classic. Lightning never strikes the same place twice. Sounds poetic, but it's just not true. Take the Empire State Building. It's struck by lightning over 100 times a year. Tall structures act as magnets, not shields for lightning. Why? Lightning seeks the easiest path to the ground, and tall, conductive objects make that path shorter. During a storm, a huge electrical potential builds between clouds and ground. Lightning forges a channel of ionized air, a plasma, that acts like a wire. Skyscrapers provide a convenient launch pad for this electrical discharge. Lightning isn't random. It follows the laws of electromagnetism, always choosing the most efficient route. That's why lightning rods exist, not to prevent strikes, but to attract and safely channel them. The idea of lightning as a one-time event is a myth. In reality, it's a repeat visitor to the same spots. The next time someone repeats the old saying, picture city skyscrapers patiently waiting for their next encounter with the storm. Lightning is a creature of habit, not a rare fluke. It's governed by physics, not folklore. So, yes, lightning can and does strike the same place over and over. The myth is shattered by simple observation. Our cities stand as proof lightning loves a familiar target. The truth is electrifying, literally. Don't believe the myth, believe the science. Now, let's journey back to space and face the black hole myth. These cosmic enigmas have captured our imagination for decades. But what do we really know about them? Hollywood paints black holes as cosmic vacuum cleaners, sucking in everything nearby, devouring stars and spaceships without mercy. But black holes don't suck. They're just incredibly dense objects with powerful gravity, not cosmic predators on the hunt. If our sun were replaced by a black hole of the same mass, Earth's orbit wouldn't change, just the light would vanish. The gravitational pull would be identical, and our planet would continue its path only in darkness. Black holes only affect things that get too close, crossing a boundary called the event horizon. This invisible line marks the point where escape becomes impossible. The event horizon isn't a surface, but a point of no return, where gravity is so strong not even light escapes. It's a boundary, not a wall, and nothing can signal back from beyond it. From far away, a black hole's gravity is just like any other object of the same mass. Planets, stars, and even light can orbit safely at a distance. The danger is only near the event horizon. As long as you keep your distance, you're perfectly safe. Think of it like a waterfall. Paddle near the edge and you're fine. Cross it and there's no coming back. The analogy helps us grasp the invisible boundary's significance. Black holes aren't cosmic monsters roaming the galaxy. They're the final state of massive stars, following the same laws of gravity as everything else. They're a natural part of the universe's life cycle. Their behavior is predictable, not predatory. They don't chase or hunt, they simply exist, shaped by the physics that govern all matter. They warp space-time, creating a gravitational well so deep that light can't escape. This warping leads to some of the most mind-bending phenomena in the cosmos. Orbiting a black hole from a safe distance would be stable, just dark and cold. There's no drama unless you venture too close. The key, don't get too close. Respect the boundary, and you'll be fine. The myth of black holes as active hunters is just that, a myth. They're not lurking, waiting to pounce. The reality is passive, inescapable physics. Black holes are governed by the same rules as everything else in the universe. Black holes are not out to get you, they're just extreme objects obeying gravity. Their presence is dramatic but not malicious. The universe's most mysterious objects are less like monsters, more like cosmic endpoints. They mark the end of a star's journey, not the beginning of chaos. Don't fear the black hole, respect the physics. Understanding them reveals the true wonder of our universe. The truth is stranger and far more fascinating than fiction. Black holes challenge our understanding, and that's what makes them so captivating. Let's come back to Earth and hop in a car. As you take a sharp turn, you feel pushed against the door. Centrifugal force, right? But physicists call it a fictitious force. How can something that feels so real not actually exist? It's all about perspective. Inside the turning car, you feel an outward force. But from the sidewalk, there's no outward force, just the car door pushing you inward. Your body wants to keep moving straight, thanks inertia. But the car turns, and the door forces you to follow. The real force is centripetal, pulling you toward the center of the turn. What you feel as centrifugal force is just your body's resistance to changing direction. It's the same principle that keeps water in a spinning bucket or separates clothes in a washing machine. The inward force is real. The outward force is a useful fiction. In physics, centrifugal force helps explain things from your moving perspective, but it's not a fundamental force. It's a phantom, born from motion. The next time you're pinned to the side of a roller coaster, remember it's inertia and the real inward push that you're feeling. The outward force is just your body's stubbornness to change. So is centrifugal force real? Not in the way you think. It's a trick of perspective, a ghost in the machine. The sensation is real, but the force is not. Physics clears up the confusion, one turn at a time. For our final myth, let's travel back to ancient Greece, a civilization where philosophy and science first began to intertwine. Here, thinkers like Aristotle shaped our earliest understanding of the world. Aristotle believed heavier objects fall faster than lighter ones, a truth that lasted nearly 2,000 years, influencing generations of scholars and shaping the way people saw the world. It feels obvious. A bowling ball drops faster than a feather, right? We see it every day, and our senses seem to confirm it. But Galileo challenged this ancient idea, famously dropping objects from the Leaning Tower of Pisa to show that, in the absence of air resistance, all objects fall at the same rate, no matter their weight. On Earth, air slows the feather, not gravity. The difference we see is due to the invisible force of air pushing against the feather as it falls. The feather's large surface area and low density make it much more affected by air resistance, causing it to drift and flutter slowly to the ground. The bowling ball, dense and streamlined, cuts through the air easily, barely slowed by the atmosphere as it plummets downward. The real difference is drag, not weight. Drag is the force that resists motion through air, and it acts differently on different shapes and sizes. To see gravity's true nature, we need a vacuum, a place with no air at all, where drag disappears and only gravity remains. In 1971, Apollo 15 astronaut David Scott performed a simple but profound experiment on the moon. With no air, no resistance, he dropped a hammer and a feather side by side. Both hit the ground at the same time, a moment that stunned viewers and confirmed Galileo's insight for all to see. Gravity accelerates all mass equally, regardless of size, shape, or material. This is a fundamental law of physics. Heavier objects are pulled harder, but they also resist acceleration more. These effects perfectly cancel out, so everything falls together. In a vacuum, a feather falls as fast as a hammer, a piano, or even a planet. The rules are universal, applying everywhere in the cosmos. The universe doesn't play favorites. Every object, big or small, is treated the same by gravity's pull. The sight of a feather and hammer falling together is a testament to the power of questioning assumptions and the beauty of scientific discovery. Science advances by testing even our most obvious beliefs, daring to ask questions and seek evidence. The laws of nature are more elegant and fair than our intuition suggests. They reveal a hidden order beneath everyday experience. So, next time you drop something, remember, it's air, not gravity, that makes the difference. The truth is often more surprising than it first appears. The universe's true laws are often hidden in plain sight, waiting for curious minds to uncover them. The myth is busted, the science is beautiful. Gravity treats everything equally, and that's a wonder worth celebrating. We've journeyed from orbiting satellites to thunderstorms, black holes to car rides. The laws we take for granted are often just the beginning of a deeper, more fascinating story. The universe isn't ruled by common sense, but by subtle, beautiful rules. Understanding these truths deepens our wonder. Each myth we bust brings us closer to the real story of our cosmos. So next time someone says lightning never strikes twice, you'll know the shocking truth. Smash that like button, subscribe for more science myth busting, comment your favorite physics myth below.